Hi everybody, today we're going to do composition of functions. So if you find that page of notes that says composition of functions on it, that's what I'll be using. Composition is actually something that you've done in Algebra 2. You may not remember, or you may have thought it was difficult. Hopefully it's a little bit easier the second time you do it. So just to kind of remind you, this is what it looks like. It's an open circle, so it's f of g of x. That's how you say it, f of g of x. Or it could be written this way, f of g of x. This second way is a little bit more descriptive in the way it's written, this notation. You can actually physically see that the g is inside f, and that's essentially what we're doing. It's substitution. You're substituting one into the other. We're going to start off with some numbers, and then we'll get into some variables. So again, just like anything with math, you start with the parentheses that are on the inside. So we're going to start with g of 2. And I'm going to write it out. If you can do it in your head, great. I want to go through some difficult examples on purpose. So don't expect the easy examples. I'm going to do the hard ones, and maybe your assignment's a little bit easier. I think that just makes more sense. So this is telling you the opposite of something squared plus 1. It's the opposite of 2 squared, since that's what we're putting into it. So it's not negative 2 squared. It's the opposite of 2 squared. So it's negative 4 plus 1. So that's negative 3. Now that's not the answer, because now what we have to do is work our way back out, and we have to do f of negative 3. And for f, it's 2 times something minus 3, and that something is a negative 3. So we get negative 6 minus 3, and the answer is a negative 9. So that's the answer to the whole problem. On the second function, again, start on the inside, f of 2. And f says to take 2 times something minus 3, and we'll plug in the 2. 4 minus 3, and we get a 1. Now we're working our way out, and we're going to do g of 1. And this says opposite of 1 squared plus 1. So we get negative 1 plus 1, which of course is 0. Parentheses will help you in knowing where to put something. It will also help you in knowing like how to take care of your signs, when do you have to distribute, things like that. Things that are easy to make a mistake on, super easy to make a mistake on. And mistakes that I know you can distribute, so it seems silly to make a mistake there. So now let's take a look at these. We're going to do the variables, no more numbers. Our answers will have x in it. So again, you start with g and you put that inside f. So I'm going to start here. I'm going to put that into f. So f says something squared minus 5, and my something is x minus 3. Well, be careful with this. A lot of people think you distribute that power, and you do not, because the minus sign. This is a binomial, x minus 3 times x minus 3. The minus 5 is, of course, still there. So this is x squared minus 3x plus 9 minus 5. Which is x squared minus 6x plus 6. Oops, that's a 5. I can't read my own writing, so it plus 4. Let's try this one. This one says to take and go the other way. We're going to take f and plug it in here for g. So this says something minus 3, and the something is x squared minus 5. So this is just x squared minus 8. Here, the parentheses didn't change anything, which is a little bit unusual and just a little bit lucky. Now, f of x, it's not a typo, it's really f of f. So we're going to take f and plug itself back into it. So we have something squared minus 5. And that something is, of course, x squared minus 5. Squaring a binomial is so important in our class that I'm going to go over it again. So I'm going to write it twice. And I'm going to use FOIL, distributive property. If you need the box, you'll have to do that yourself. So we get x to the 4th. Remember, when you multiply, you add the powers. Negative 5x to the 5th. And then inside here, we get another negative 5x to the 5th. That's not right. X squared. Sorry, you're probably like, wait a minute, what? So then x squared minus 5x squared again. And then negative 5 times negative 5 is a positive 25. And then the minus 5. Now, when you add, you do not change the power. So we have x to the 4th minus 10x squared plus 20. This kind of brings up the issue of what about the domains? And in all those problems, the domains would have been all real. So you weren't asked to do it, but not every domain is all reals. So in this problem, these next couple, they're asking you specifically about the domains. You know, we have domain restriction with a fraction or with a radical, and here we happen to have a fraction. So we know right away that if we set the denominator not equal to 0, x cannot equal to 0. That might be our only restriction, but it's definitely a restriction, and we keep it throughout the problem. So we're trying to do both compositions. We're going to do f of g of x. I'll do that one first. So that means take g and plug it into f. Well, that's not too hard. So f says this, 1 over something, and the something is 2x minus 1. It's actually finished. But the problem is we have a denominator that we didn't have before, which is going to create a domain restriction. So 2x minus 1 is not allowed to equal 0. So 2x is not allowed to equal 1, and x is not allowed to equal 1/2. So our domain restriction has to be all the things, all the restrictions. There's no way to combine these two as they're separate numbers. So the domain then is x cannot equal 0 or 1/2. Let's go the other direction. So now we're going to take f and put that into g. So g says 2 times something minus 1. Our something happens to be 1 over x. This probably doesn't really simplify too much. I'm just going to get rid of these parentheses. So 2 over x minus 1. We did not introduce a new denominator. The denominator has always just been x. It's not any different. So our domain is just that x cannot equal 0. Let's do this one with the radical. Right away you can see we have a radical, so we know that the radicand, the x minus 2, has to be greater than or equal to 0. So now we're dealing with x is greater than or equal to 2. That might be our only domain restriction, or we might have additionals. F of g of x. So we're going to start with g, and we're going to put that into f. So f says 3 times something plus 5. And we'll put this right into here. The parentheses aren't really doing anything there. So you can have them or not have them. That's up to you in this case. They're there, so I'm going to leave them there, as you can't distribute a 3 throughout that radical sign. Turns out we did not create any new radicals or denominators, so the domain is simply x is greater than or equal to 2. If you don't normally do your domain restrictions first, I would recommend it, because it's like one less thing to think about. All right, so then the next one is g of f of x. So now we're going to start with g and put f inside. So g says the square root of something minus 2, and our something is 3x plus 5. So now we get the square root of 3x plus 3. So now we have to say, okay, that has to be greater than or equal to 0. So 3x plus 3 is greater than or equal to 0. So 3x is greater than or equal to negative 3. X is greater than or equal to negative 1. Well, we have to think which one is more restrictive. And I'm going to use a number line for this. I'm just going to do it down here. So here's 0. Here's negative 1. Here's 2. This one says x is greater than or equal to 2. So it's like that. This one says x is greater than or equal to negative 1. And you have to ask yourself, which one gets rid of or does not include the most numbers? At 2, we don't include anything all the way to the left. So this clearly is a little bit more restrictive. So the domain here, got to pick the most restrictive. There's no way to combine them. So we're going to just pick the one that is x is greater than or equal to 2. And we don't care about this one because this one automatically includes this restriction. Now this last little bit, we're going to go backwards, which sounds like it might be harder, but it's actually not. If you think of it as something rather than just always just x. Let me explain to you what I mean by that. So it says we're going to do this the other direction, starting with the composite. So starting with h of x, which I forgot to put this in there, but h of x is really f of g of x. So I added that in. Sorry, I forgot to type that in as I was doing it. And so what we're going to do is we're trying to figure out, well, which one is g and which one is f. Well, we want the inside, or the outside rather, to be the something. So like if I look at this, I think of this as something, wherever the x is, just think something minus 5. The something is the details. So the something is the inside function, so the something is the g of x, and then the generic function is the f of x. So this is just something minus 5. But my something, my specific something, is 1/2 x. So let's take a look at this one. So we have f of x and g of x. So we have 1 over something, 1 over something. And the something is x squared plus 3. Because that's the whole denominator, you can lump the something all together. What you can't deal with is number 10, something squared plus 6 times something plus 9. Like, there's no separation. So we can't really have the letter written more than once. That's the issue. So there's a little trick to this. We've got to factor it. Multiply to get x squared. Two numbers that multiply to give you 9. 9 times 1, or 3 times 3. And when you add those up, you get 6. Well, that's going to be 3 and 3, plus and plus. I'm going to rewrite this as x plus 3 quantity squared. So it's something squared. So I have f of x, I have g of x. So this is going to be something squared, and my something is x plus 3. And that's called decomposition or decomposing. And you will be asked to do that again in the future. So please be sure to do your assignment and have a great day.